Okay, going back to this thing, this abomination of a design. I had a look for some exotic diodes and had some thoughts. I tried some more decoupling. I wonder if it was the relation of the inductance to the internal power supply and a very poor quality capacitor, so I put a 470 nanofarad polyester film capacitor across the main smoothing capacitor. It reduced it by a couple of amps, 3 amps, 4 amps, but not enough. So you can't really easily get these diodes which are going to solve the problem. When you turn this thing off, and if you monitor it, I'll show you on the screen actually, it goes wild. As it shuts down, you can hear some instability kick in, and then you get a peak of about 60-70 amps on the current. So I'm going to use 2 diodes with a small series resistor to balance the currents between them. If one of these has got slightly different forward bias current or a slightly resistance of bonding wire, then they won't share the current equally. So a small resistor, I'm talking less than an ohm, probably half an ohm, quarter of an ohm resistor in series with each, will help them share the current and make it reliable. It's a nasty design, so cheap and so marginal for a single-ended power supply, to be honest. And let's face it, they're all pretty much like it. Do you know a reliable single-ended 50 watts power supply? All the Dell ones and everything else would use a half bridge in the output stage. So what we're going to do is going to fix these 2 on. So we get a scalpel. Get a scalpel. Get a scalpel. Where the fuck's a scalpel? There it is. We're going to get a scalpel and we're going to remove this piece of solder resist on this part of the tracking. Right, so I've cleaned off the tracking off this area here next to the, on the other side of the FPT. There's not really room to do this on the other side, and I don't like squeezing things in, especially when there's higher voltages involved. So we soldered one diode onto there like that, with the bar facing towards the top of the board. And the other diode, if I can find it, we can solder on. Okay, so we've got one on there. We're just going to solder the other one on. Right, so we've got one on there. We're just going to solder the other one on. Come on. Make friends, get married. There we are. So they're on. Let's give that a bit of a clean. Isopropyl. Right, the name of the game is to get a resistor on the end of each one of those, and we want about half an ohm, I think. Half an ohm. So we're getting a half an ohm 0805 on the end of each one of those. It's going to be tight on the left one, isn't it? Be mindful of the tracking distances on this thing. That's the only problem. Well, it's lacquered, it's alright. It'll be okay, but make sure you don't get too close to this plated through hole there, or you don't scrape any of the solder resist off. Interestingly enough, my kit has got 0.43 ohms, so I'm going to put a couple of 0.43 ohms. You think that would, actually that's more than enough, isn't it? I think we'll go lower actually, lower, 0.2 ohms. 40 amps at 2.2 ohms is 0.8 volts, which is plenty, which is more than the forward bias voltage of the diode under load, so it'll share the presence of these 2 separate resistors. Will share the current if there is a difference in the forward voltage drop on these diodes. Let's put a bit of solder on the end of these diodes. I'm going to mount them vertically, by the way. Okay, so we're just going to solder these 0.22 ohm resistors, 0.2, 0.3, 0.4, anything like that will do. So let's find the location where we're at. Where are we at? We're over here. There they are. Turn it around that way so I can... I hate wires, don't you? Hate wires on the bench. Why can't everything just be cordless? That was a rhetorical question. I tell you, the person who hates wires less than me is my missus. It's not to do with the food blender. So there you go. I've soldered the resistors on there, mounted on top of the components. They're less height than this, so they're not going to hit the case. You can see that? Can you see that? So we just need to put a link wire onto these two and then connect it to which point, that point there. So a little high actually we could use a piece of the Kynar, couldn't we? Bit of Kynar modification wire. That's this stuff, temperature resistant wire wrapping, but it's good for mods as well. There's the RS stock number. It is temperature resistant as well, so you don't want to put a piece of PVC, although PVC would be good for about 150 degrees. Actually, would that be enough, do you think, that insulation on there to go across that 0 volts to there? Yeah, I think it would. It's amazing if you haven't got an air path how good insulation is. We might put a bit of Kapton underneath just to make ourselves feel a little bit better about this bodgy repair. I mean, I wouldn't do this on a design, I would do a proper job. But this isn't a proper job, is it? If I had a proper job, I'd be working. Right, okay. So 0.22 ohms, we want to bring this wire to the middle somewhere. Have the equal length, so actually I want to put 2 layers of fairly equal length in rather than 1 wire, and then otherwise we might upset our power sharing scenario we've got going on. So that one goes to there, goes on to the end of this one here. Yeah, the things we do to save things going from landfill. But I have just had a revelation. I might have produced the only reliable CTEK battery charger on the planet. It's got to be worth something, isn't it? Worth than a normal. If it's £60 for an unreliable one that's going to blow up and cause you problems, how much is one that will probably never go wrong worth? Well, £60 and about 40p for the components, isn't it? I'm very sceptical about these marketing claims. These companies that spend a lot of money marketing these different products, I'm very sceptical, because I'll tell you why. Some of the reviews of some of the products, like Gorilla, for example, Gorilla Tape and Gorilla Glue, a lot of the Gorilla products are virtually bloody useless when they're tested. It's like Duracell batteries, they're all marketing. So they might be expensive, you know, you might pay, they might be reassuringly expensive for you. You know, a 5p battery for 25p or something, or whatever it works out at. But the point is, the bottom line is that the extra high reassuring cost that you're paying, in many cases, not all, but in many cases, I've discovered that the reassuring extra cost is actually marketing. So you're paying for it. You're paying to be sold a dud product in a lot of cases. So what we want is proper testing, but there isn't any proper testing. Which magazine in the UK claims to do proper testing, but I don't really go down to the right level you need to do for an electronic product. You need to go inside it and have a look, see what's going on, see what schoolboys designed it. There we go. So what I'm going to do is, before I bag this up, lift the wire off the board slightly just to give it an air gap, and I'm just going to put some non-conductive, non-corrosive, neutral cure silicone on those wires just to hold them in position, stop vibration getting to them. But that's the modification. Give it a bit of a clean, So we've got 2 diodes. The bar on that diode is there, the bar on that diode is there, going to the same point as this went to here. Then a 0.2 ohm resistor on each end of the diode with an equal length of wire, roughly to the point where it was going to before on the end of the snubbing capacitor and snubbing network. So that's our snubber rewired with 2 diodes and some series resistors, so it'll give, in theory, give us up to 60 amps. Not an ideal situation, not a great design, not good at all. Well, a load of crap really, to be honest. But yeah, it's got Lots of lights. Look, all these LED drivers down here for the lights. If they used the right micro, they wouldn't have had to. If they used a couple more pins, they wouldn't have to multiplex it, would they? Yeah, and a load of smoke and mirrors circuitry down here for all the analog testing of the battery and the reconditioning. Have a look at the other video on the reconditioning. It made no difference to my battery at all. A failing battery, but you know, people love a nice shiny gold case. It's gold. Look, see, we've got little numbers over the. Lovely. I put the batteries on this on the timer, and from there to there it's not doing anything. It's just a timer turning the lights on. Yeah. Smoke and mirrors. Just buy my battery charger. It's the best one in the world. Oh, all right then. Yeah. So let's let it dry off. Do not turn a board on, power board on, soaked in isopropyl alcohol. I've done it a few times. Lost my eyebrows once. Right, should we try it out and just see if it's working then? Have I forgotten anything? No, so let's put 240 of Our Majesty's volts on. So, contact. Yeah, well that's working. It's well what I would expect. Hardly a complicated repair. So that's my mod. Put two of these on. Two of the original diodes on, like that. US1M-E3, basically 1000 volt, hyper fast rectifier diodes, 1 amp, 30 amp peak current, and put two in basically essentially in parallel like that, with little wires going around with a 0.22 resistor on each end, which you can see by going there. Yeah, don't forget this is powered up, and a bit of sleeving here. So you can see you've got 0.2 ohm resistor and a 0.2 ohm resistor there to do the job on two of the diodes, so they're sharing that peak horrible current. So you know, we put an extra 50% error margin in this product, or margin of safety in that design part of the circuit. My guess is it's a shittily designed power supply, and now that we fix this problem, you might find after another 500 hours or something, or another problem will come to light, because it is a sparsely populated power supply. And the one last thing I'm going to do, if I can find it, is to get me power supply box and fish out a varistor, and we're going to protect her. I'm going to give her a bit of protection. Yeah. Going to stick this varistor in the unit. Can't see it, there it is. 275 volt varistor across the supply after the common mode choke. Common mode choke being in there. I don't know. I don't think. I'm still can't believe that there isn't one on here actually, or even the place to put one on. Where no, we can't bother to fit that because it's just too expensive. What you're talking about? Don't fit that. We have no need for special devices. I worked in an electronics place in Japan for a while. Christ, the engineers are absolutely shit scared of the management in Japan. Not good at all. Is that too thick, do you think? What else is in this case? There's nothing down this end, is there? Look, we're pretty vacated, although there is a curve on the lid. You can see this curvature. Might curve down and have less space at that end. So I'm trying to find somewhere to fit this without... It's obviously got to go after the fuse. Can't put it before the fuse. There's nowhere obvious to put it, is there? You'd think there'd actually be some holes for it somewhere. Got your two caps though. You've got the input filtering cap on both the live and neutral, and across live and neutral. There's no. They've got a balancing resistor network on there, but they haven't put a balancing capacitor network on there to a center point for grounding. And that point would normally go around to here, but they haven't bothered with that. Is there something on the other side? No, there's nothing on the other side. It's completely bloody empty, really. Yeah, so I could take all this off. I don't have time for this, boys. Put it across that cap there. I'm not sure the case will fit. That's the problem. That's your problem. Do I really have to get bloody drill out and drill some bloody holes in it? Do I? I don't think the case will go on because it's curving down towards here and it's going to get pretty small. Or is it actually? Is it? Let's just try it in the case and see whether it will fit if I put it on the... If I do a complete bodge. So I'm going to do a complete bodge here. Right, it's turned off. Make sure. Little Christmas tree of LEDs. Look all those lovely LEDs it's got. Look. Yes. Have a little battery charger, £15. £5 a LED, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. So almost £5 on each LED on this thing that makes you feel like you're happy is costing you a fiver. See? Good job they didn't put 15 LEDs on it, wouldn't it? It'd be 75 quid otherwise. Well, if you're watching CTEK, by the way, I'm happy to fix all your design errors for you and give you some critique of your designs before you actually sell them to anybody. That's pretty unkind. Otherwise I'll start an evil battery charger empire on my own and mine won't go wrong. Oh, I know. How about that? That's a good idea. Is there room for that though? There is on this side, isn't there? It's all post fuse. Yeah, that's a good idea. You were screaming at the screen probably, so don't be such a dick. I would be anyway. I'll take this cap out. Always use protection. That's what my mum said. And she was right. When I went to university in electronics, it was true. As a prophylactic. Right, here we go. So I can get this to come out. Yeah. Take it all, bitch. Right, so what we want is to put this back in, straighten its legs up. What have we got there anyway? Yeah, so it's a 0.047 250 volt AC, 275 volt AC, Chinese AC. That means about 185 volt reliable operation in normal Western units. Okay, don't forget the voltage ratios on Chinese capacitors are in Chinese units, and one Chinese unit equals at least 1.5 Western unit. So if you want to make a reliable product, don't let a Chinese low-cost engineer choose your capacitors for you, because you'll be in the shit. The Chinese comical party. Right, so how are we going to get that go back in there with the intrinsic lack of space in this thing? I think it will go on that side, won't you? So these are going to be married together. I thereby wrap you in electrical matrimony from this day forward, for better and probably for worse, to be honest, let's face it. What we're going to do, we're going to go around to get the same pitch, so we're going to go around like that and back down there. Ooh. Was it good for you? When you've only got cutters, everything starts to look like a pair of pliers. This would have definitely got me a clip round the ear from my dad. He worked for Rolls-Royce. In the tool room during the war, actually. He very proudly told me that they made the first thread rolling dies, which were used to make very high tensile bolts for things like engines. And quickly, rather than cutting the thread, you rolled it between two hardened steel plates at high temperature and roll the thread on. Thread rolling. Right, so they are married in electrical harmony. So the voltage over this goes over 275. This thing will go, oh no way, Jose, and conduct. And for most transients, it'll soak up a lot of power before it goes pop. But if you hit it hard repeatedly, it will denigrate and start to break down. And I've seen these with holes clear through the middle. You look at my other videos, they turn into little fire bombs, little arc welding things when you really hit them with something like, well, possibly lightning, I suppose. Right, so let's put this back in. We'll slide back in the protection. Hopefully it all will fit. Go on, in you go. Yeah, look at that. It's perfect. Perfect. Oh. Trim my toenails. I'm happy to see the back of this bloody thing. I thought I would just mend it, I didn't realise I'd end up modifying it. So we put the protection in to stop any overvoltage, so it'll make it much more reliable, because I've never seen one without a varistor in it. I don't understand how you can do that. But, you know, they know what they're doing, don't they? No, they don't. It should... Oh, it is. Yeah, it's on the right side of this choke, because I don't mind if you get a high energy spike come through, then this common mode choke will help to filter some of it out, certainly high frequency content, and reduce the energy, so and block the energy from getting into the unit. So this is your last resort. We've got this shitty little capacitor. This is supposed to be on the application data sheet for that. This is supposed to be 75 microfarads. They put a 47 in. Depends somewhat on the quality of the component, but for the 60 Hertz market, obviously you need a smaller one, but for our English 50 Hertz, because we like to do things slower in the UK, all our motors go around slower, all our synchronous motors and everything, so even compressors produce less air on 50 Hertz than they do on 60. But that's a small price to pay for being British, well, English in my case. Right, yeah, so this that's it basically. It's done. I don't want to bore you by showing how to put it back together. I've got my titty button things come off. Okay, so there we are. So finally, she'll go and get the silicone. Yeah, so stay at this tube. Don't burst on me. It's coming out now. So what we want to do is get a bit of a cocktail stick, or in this case a kebab. There's a thing about getting kebabs from the local kebab. Ah, oh, God, look at that. Why does this bloody stuff go everywhere? Scoop it off there. Talking to you guys that did it. Put a dob on there. Hold that wire off. And lift that wire up under there. And put a dob. Not turned on. Check it's not turned on. Lift that up. Make a right bloody mess of this, aren't I? Let's face it. And my bench. And then finally a little bit just to support these components in their position. Stop them bouncing. If there's any nasty vibration, it'll do the job. Most of the silicon is actually I shipped a test system from test systems from the UK, and the stuff's going everywhere, to Japan. This was in the 80s, and it went on a diesel ship near the engine compartment, and my God, the vibration just shook the whole thing apart. When it arrived in Japan, half the chassis screws and everything had fallen apart. It was a complete mess. It was a right eye-opener, and it was due to the vibration of the engines. You know, the diesel's running day in, day out on a 6-week journey. It just shakes your product to bits. And then things like upright electrolytic capacitors, you know, the big smoothing ones, bloody legs break off and all sorts, because they're wanging about, and vibration, if it happens to be anywhere like their normal natural vibration from the engine, you're in trouble. So that's what the silicon's for mostly. But yeah, and now I've got it everywhere. Right, I want to clean up. You don't want this to be cleaning up. Right, it's all done. There you go. So it's got a bit of silicon on it now. It's got the varistor fitted underneath, and I've cleaned off all the extra silicone. That's silicone stuff, this stuff. Let's get some more actually. It's about £2 or £3 a tube from AliExpress, but it flows nicely, and it's got the right sort of properties and the right price, and it doesn't tend to go off too much. That tube's probably about a year old, but since it hadn't had the cap on it, it was actually quite easy to unblock. It's workable stuff, all right. So that concludes the video. That's the modification. If you want some diodes and the resistors, get in touch. I can send you a few for the price of the postage. Yeah, so there, I hope you enjoyed that. So I'll do a load test on it now, but you can see all the other load testing stuff that's done on the other CTEK videos on the channel, so I'm not going to do it on, spend some time making a video about this. But yeah, so that should now be reliable. I'm going to ask the guy, I'm going to send them back the battery charges, and he can let me know if anything goes wrong, but assume it's got to be a lot better than it was, because it's clearly over current, that diode. Bad design, expensive, cheap design from China. Hope you enjoyed that. If you want to see more videos, then obviously you know the routine. Press the titty button down in the corner and leave me a like, because I like likes. Thanks. Good luck if you're repairing yours.